Good morning, everyone, and happy Republic Day. Today is 26th of Jan, and today's lead code challenge is question number 576 out of the boundary path. The question statement says there is an mn to n grid with a ball. As you can see in the image, the ball is initially at the position start row, start column. It means it's at a starting point. You are allowed to move the ball to one of the four adjacent cells in the grid, possibly out of the grid, crossing the grid boundary. So we are allowed to move the ball in any way, any direction we want. We have four options, all the four directions. Okay, yeah, so we can do that, and we have at most max move, that we have a limited number of moves which we can perform. So we have to, given the five integers m and max in max move start row start column, return the number of paths to move the ball out of the grid boundary. Since the answer can be very large, return it modulo 10 to the power 9 plus 7. Okay, so here what we have to do, we have to return the number of all the possible paths which lead to the lead the ball out of the grid. That means all the possible paths in which the ball can travel to finally get out of the grid. So it looks like a recursion question to me, and the constraints are not very high. So let's first try to make this solve this problem without choosing dynamic programming, just using recursion, and let's see what happens, and if we are able to solve it or not. So let's first off, so I'll just tell you the strategy we are going to be following here. I'll just tell you the way. So here we are at hold on, yeah, so let's assume let's assume we are at a starting point. Let's call it start. Okay, now at start, what options do we have? So here we can check if we have, I mean our if we have moves left. That means we have not yet used our max moves, we still have some moves left. Then we have four options: either we can go this way, we can go this way, we can go this way, or we can go this way, right? We have four options, and now we can choose from any of these four options, and then we'll reduce the moves. That means max, or we can call it move l mole moves left not equals to 0. So we can do this. And one more case, if we reach a position where we found ourselves out of the grid, then we will be returning 0. And we'll, in every like, we'll get four cases in every position here. So I hope you understand. For every position we'll be having four cases. First one is going to be A, that is going to be in the north direction, and B will be in the east direction, C will be in the south direction, and D will be in the this direction, yeah, in the west direction. So we will be having four cases, and we are going to um, uh, you know include all these four cases in our recursive function. So let's describe our function. This is our recursive function. What are the arguments we are going to be needing here? So we are going to be we need m comma n. That means we need the information of the size of the grid. Then we need moves left, so we can write it m o l, moves left. Okay, So these are the number of moves we have, and we also gonna need our current index, that means I and j. These are our current indexes, that means our current position. So inside the function, what do we need to check? If we still have moves left, or if we don't have moves left, or simply if I is less than 0, or I is equals to m, right? Yeah, here m is equals to 1. Yeah, so if I is equals to m, or j is less than 0, or j is equals to n. Okay, so if any of these conditions satisfy, that means that we are out of the grid. So we're going to return 1. So we can count this case because we have reached out of the grid. So we can count it. Now if we are out of moves, so if mol equals to 0, in that case we are going to return 0. This case says that we did not reach the out of the grid in our limited number of moves, so we are now out of the moves, and we have nowhere to go, so I'm returning 0. And the next case, now we are at a position where we can call these 4 cases. So we are going to call for a, that is going to be function of m comma n comma moves left minus 1. That is going to be moves left minus 1, because we are making movement here in a way. So for a we are going in the north direction, so to move to north we have to do I minus 1, and j will remain the same. That's it. Now we're just gonna copy this, and for b paste the same thing, and for b we need to move to the east direction, that means j plus 1. Similarly for c we need to go in the south direction, that means ai plus 1. And for d we need to go in the west direction, that means j minus 1. And at the end we need to return a plus b plus c plus c plus d. We're returning this such that for if we moved in a, and if we reached if we reach our destination, that is out of the grid, by n number of cases, and we are going to count those n number of cases along with the cases in which we moved to the east and found our destination. So we are just going to return the sum of all these cases, and that is going to be our answer. And let's try to call the function here also. Done. So here m and n are going to be same, and max move is going to be max move here. Number of moves left is going to be max move, and I is going to be our start row. The start row is going to be I. Start column is going to be j. That's going to be our solution. Let's try to run it. So we do have an error here, and that error is a syntax error. Now let's try to run it again. As you can see, we are passing the first two test cases. Let's try to submit this. So after reaching this point, we see that we have having a time limit exceeded. That means our solution is not very fast. Now, what are the options we have? We can use dynamic programming. So we are going to use it. Now, what do we need to memorize here? For all the repeating cases, in the cases where we have same number of moves left and we are at the same position, in that cases we will need to return the same output, right? So like if these three constraints are same, then the output needs to be same, right? So we'll just use memorization here, and here we need to pass an empty dictionary. We need to pass memo in all the recursive calls. In this case, this case, this case, this case, and here we are going to be storing. We are going to be checking if our I, J, and MOL are present in memo, are present in our memoization function, then we are going to be returning. So what does this statement says? This statement means that we have already processed this data. We have already gone through the calculation which we required to do in this case, where I, J, and MOL are these values. So we don't need to do it again. We'll just return return I, J, MOL. Okay, so we'll just return this, and here we are going to save the data here. So in the memo of I, J, and MOL, we are going to save A plus B plus C plus D. So we need to save this, and we are ready to run. So let's see if we face any errors. We don't have any errors and our solution is running. Now let's try to submit it and see if we are able to submit it. Yeah, so here we face a wrong answer here. Okay, so at 81st we see that our output have exceeded this. So we have missed one thing. It was clearly given here that the answer is going to be very large and we have to return it in modulo. So for that, what we need to do is we'll just write here a modulo of 10 to the power 9 plus 7, right? And yeah, so why don't we just use this test case? Okay, copy it, test cases, add a test case. Okay, so I think there must be a way to use this test case. Okay, I think we are good to go. Let's see if our solution runs. Okay, it's running properly. Now let's see if we are able to submit it. And yeah, we do have a submission. And guys, you can see that we have a pretty good ranking here because we are very close to the least, I mean the minimum time. So yeah, we are only 3.47%. We are among the 3.47% of people who solved this question. So we are in the top 5 out of 100. Yeah, we are in top 5%. We can make this even faster, but it's going to be a little difficult. It's very difficult to reach the top always. You can reach here very easily, but from here to here, it's a long distance. So yeah, that's the solution. Thank you for watching.